Hey everyone! Welcome back to DG Tutorials. Ready to ace your math exam? Whether you're feeling confident or a bit nervous, we've got you covered. Today, I'm breaking down everything you need to know about surface area and volume for grade 10 math. These concepts are crucial, not just for exams, but for understanding the world around you. Let's dive right in. We'll start with the basics and build our way up. First up, we've got the basics: perimeter and area. These are the building blocks for understanding more complex shapes. For a triangle, the perimeter is the sum of all three sides. It's like walking around the edge of a park shaped like a triangle. And the area? That's half the base times the height. Imagine cutting a rectangle in half diagonally. That's your triangle. Next, rectangles. These are everywhere, from your smartphone screen to your notebook. The perimeter is just twice the sum of the length and width. Think of it as walking around the edge of a rectangular garden. The area is the length times the width. It's like counting the number of tiles needed to cover a rectangular floor. Now let's talk about circles. The perimeter, or circumference, is 2πr, where rr is the radius. Imagine wrapping a string around a circular pizza, and the area is pr squared. This is like finding out how much cheese you need to cover the pizza completely. For parallelograms, the perimeter is the sum of all sides. And the area? That's the base times the height. Think of it as a slanted rectangle. Got it? Great.
So here we're looking at perimeter and area. We're just going to review a few shapes. So the first two that we have on the board are triangle and parallelogram. So the first one is to determine the perimeter of the triangle. So as we can see, the different lengths are given for each side. So we have 15, we have 27, and we have 35. And so simply adding all the sides is like walking around an area, whatever the shape is. You start from one point. So here we go all the way around to that side. We go all the way around here, and then we go to the end, going back to where we started. And that's how we determine the perimeter. So here we have 15. So we have 15 plus 27 plus 35, and that's equal to 77. That's the perimeter. Now, if we were to consider area, it will be the formula that's given, which is half the base times the height. So in this case, the base is always where the right angle meets with the vertical line. So here we have the vertical line, which is 9, and the right angle is making, it's like you could say the T-zone. So we have the base, which is across, and then we have the vertical line that is forming a T. Well, you could say reverse T, upside down. And then we determine that that will be the base, which is where the right angle hits the vertical line. And so that will be the base. And it doesn't matter which way it's turned. If the triangle is turned upside down, right side up, sideways, whichever way, it's always going to be that zone where the line that meets the vertical line at a right angle. And so we're saying 35 divided by 2 times 9 will give us 17.5 times 9, which is 157.5. And that will be, depending on the unit of measure, if it was centimeter, it will be centimeter square. And if it was just a perimeter, it will just be centimeters. Okay, we won't have a square there. And for the parallelogram in this case, we didn't have to write 5 twice because this side is equal to this side, and this side is equal to that side. So it's simply doing the same procedure, walking around the block all the way around until we get back to the starting point. And then we add all the lengths. So we have the 2 sides, 2 short sides, 2 long sides. So we have 5 plus 5 plus 18 plus 18, and that will be equal to 46. And again, if it was in units of centimeters or meters, we would just simply say 46 centimeters. And if it's meters, it will be just 46 meters. The area, however, you would simply multiply the length by the height. And in this case, the length would be, again, the same principle as in a triangle, would be the side that is adjacent or meeting the vertical line at a right angle. And so that would be the side. You can't use this side, which is the 5, because no right angle is forming that area. So it would be the height. And if you notice the vertex right here in a corner, it will just come straight down. So the highest point all the way down to meet the horizontal line. And so that's why that is the base. So it again would be similar to a triangle, except in this case, it will be base times height, not half the base. So it will be 18 times 4, which will be equal to 72. And that's how you determine the perimeter and area as a review. So let's start with the trapezoid at the top. And here we have 4 sides, and then we also have inside the height. So perimeter, same principle applies as before. You just walk around the distance. So you start at one point. So say we start at this point here, and we walk around the perimeter all the way around, and then we just travel all the way around and get back to the end or the beginning point. And that's what we do for perimeter. So 11 plus 12 plus 11 plus 22 equals to 56. And again, if it's meter, that's all we're going to write. Okay. Now, the area of a trapezoid is different because here we have half of the height, which again, locate the height by determining the point, which is the vertex, the highest point. So it could be on this side too. It could be this side or the side that's given. So either side works if you're given the height. And it must be accompanied by the right angle. Okay, and it must be sitting on the horizontal line. So the vertical must meet the horizontal line. And that would be the right angle line. And then that will be determining the height. So in this case, we know the height is 10. And I put height in brackets. And then we have to determine where the A and the B is. So the A and the B are the 2 parallel lines across from each other. And it must be meeting the vertical line. Okay, so we now know that H will be the height and A plus B are the 2 vertical or horizontal lines, which are meeting the vertical line H at a right angle point. So now we know what we have to use as our items for multiplication and to put in our formula. So now we know that half of 10 is 5. That's what we have to do here. So it says half of H. So we have to determine what H is. H is 10. So 10 divided by 2 is 5, or half of 10 is 5. So that's why we have 5 here. And then we have to put in bracket the 2 lines that are parallel. So we add them. So we cannot do anything before we actually add what's in a bracket. BEDMAS tells us that bracket must come first, okay? So we have to make sure we do our bracket. So BEDMAS, just a reminder. So even when we have formulas like these, we must apply BEDMAS principle. So first we have brackets, then exponents, then division, then multiplication, then adding, then subtracting. So here we have the bracket, so we must add those 2. So it must be 34. And then once we finish that, then we can do our multiplication or division, whatever it is we need to do. So now we're going to multiply the 5 by the 34, which was equal 170. So here we have perimeter, and the perimeter of a circle is equal to pi 2r or 2 pi r, whichever way you want to put it down. It's the same thing because they're all multiplying each other. And pi is denoted by 3.14, or we can do pi d. So in this case, we were only given the pi. Pi is usually from the center, sorry, the radius is r. So from the center of the circle to the circumference, which is the outside layer of the circle, that area is called the radius. And the radius is given at 32. D is actually the diameter, which is equal to, so D is the same thing as 2 times R. So in this case, D would have been 64. So if you're not given D, you can find it by multiplying the radius by 2. Or if you're given radius, you multiply the radius by 2 to get D. And if you want to find D, if you want to find radius and you're given D, then you have to divide D by 2 to get radius. So if they gave you 64 as D, so you would have to take the D and you have to divide it by 2, which is 64, divided by 2, which would be equal to 32. And then when you're gonna find your area, you need to have the radius. So that's why it's important to have R. So in this case, it's 200.96, and that could have been meters if that was the case. And if you're given R, in this case, we have 32, we multiply 32 by 3.14, but again, we must do what's in the bracket first. It says R squared, which means 32 inside the bracket must be multiplied by itself. So it's another way of saying 32 times 32. So if you don't know what square is. And that 32 times 32 is actually equal to 1,024. So what we did, we took the 3.14, which is this right here, and we multiply it by 1,024, and then we got 3,215.36, and that will be the area.
Now let's move on to 3D shapes. First, prisms. These are like stretched out 2D shapes. The surface area of a prism is the sum of the areas of all its faces. And the volume, that's the area of the base times the height. Imagine filling a box with water. Next up, pyramids. The surface area is the base area plus the sum of the areas of the triangular faces. Think of the Great Pyramids of Egypt. The volume is a third of the base area times the height. Moving on to cylinders, the surface area is 2πr times r plus h, where r is the radius and h is the height. And the volume, that's pr squared times the height. Think of a can of soda. Now cones. The surface area is pr times r plus l, where l is the slant height. And the volume, that's a third of pr squared times the height. Imagine an ice cream cone. Lastly, spheres. The surface area is 4πr squared, and the volume, that's 4/3 pr cubed. Think of a basketball.
So let's look at surface area and volume for prisms. So the first prism we're going to look at is the rectangular prism. And the first thing we're going to find is a surface area. So the purpose of surface area is for when you need a material to wrap something, or you just need to know, like maybe the box, the size of a box, and so on. So in order to find the surface area, we're only going to find each portion as if we were to divide up the front and the back, the top, bottom, and the two ends. As you can see, the front and back is 2 times 3 times 5. How did we get that? So we had to locate this area. So front and back, so let's say this is the front and back. We call the front and back the A side. So that would be the front and back. So the other side over here would be the back. So that's how we're going to identify it. And we know that the height is 3. So that's why we say 3 times 5. So 2 of the sides, front and back, and we're going to multiply 3 times 5. So that's 2 surface areas. So that's 2 times 3 times 5, which is equal to 30 centimeters square, because it's a square of the flat surface. Now we're going to look at the top and the bottom. So top and bottom, we're going to call that the B section. And we know the bottom is underneath here somewhere, okay? So top and bottom will be 2 times 4 times 5. And we already see the 4 on the side and the 5. So those are the dimensions for the top and the bottom. So that will be 2 times 4 times 5, which will be equal to 40 centimeters square. Now the 2 ends, we're going to call that the C side, and that's 3 times 4. So now we have both of them, which is the 2 ends. So we can see the arrow pointing to those 2 ends. 2 times 3 times 4, which would be equal to 24 centimeters square. So the total surface area, we're just going to use SA for now. So we're going to say SA is the same as surface area. And that will be equal to 94. How do we get that? We add 30, we add to that 40, and then 24, and we get 30 plus 40 plus 24 equal 94 centimeters square. So the volume is different because the volume will determine what can hold in the space of that container. So the first one was just finding the material to form like a box. But now we're looking at the space on the inside. For example, if it's liquid or something of that nature, that would be determined as a volume. So now we're going to be determining what the base times the height is, and we have to find the area of the base. We can see the box is sitting on one side that's measured 5 and the other side that's measured 4. So 5 times 4, and then the height we can see on the side, which is 3. So the volume is literally the area of the base times the height. So we're going to say area AB times H, which is the height, which is 5 times 4 times 3, which is equal to 60 centimeters cube, because cube is based on 3D dimension. Any 3D shapes would be considered a cube. And that's how we perform the surface area and the volume of a rectangular prism. So here we have the surface area and volume of another prism called the triangular prism. And we're going to identify each section as we go through it. So the bottom section is a rectangular shape. And in that case, we have just length times width as a regular formula for the rectangular surface. So that's the reason why we say length times width is 6 times 20, which is equal to 120. And you can see the section here, it's sitting on the base. So 6 times 20, okay? So let me just circle that area so you are aware. So 6 times 20. Now we're going to look at the front and back. So in this case, the front and back, we're going to call that the B section. And the bottom, we're going to call that the A section. So the B section, the front and back, you can see that they look like triangles. So the front and back, which are considered triangles, we have to use the same principle or formula for triangles, which is half the base times the height. And in this case, remember that the base is usually the horizontal line, and the right angle is sitting on the horizontal line. And so the height is what we need in order to find the area. So in this case, the height, that is the vertical line that is forming the right angle on the horizontal line, is 3. So we have the arrow there. It shows that that line, the height is 3. So now we're going to use that as part of our formula. So the base is 6. We use 6 again. So 6 times 3 and half of that times 2 will be equal to 18. So that's why the answer is 18. And we just captured the front and the back. Remember the surface areas, we have to capture all the sides. Now we have a left side and we have a right side. So let's look at the left side. The left side is 3.6, which is this side over here. And we're going to call that side C. So the left side is C, which is 3.6 times 20, because each side have a different length. So 3.6 on that side times 20. So that's why 3.6 is just length times width, which is because it's a rectangle. We just say length times width, 3.6 times 20 equals 72. Now we're going to go into the right side. And the right side here, the side on this side is literally 4.2. So I didn't write that in. So there we go. So that's the length on the right side of the triangle. And because it's a rectangular shape, we have to consider that as a rectangular side. And so we have to just use the same formula, length times width, which is 4.2 times 20, which is equal to 84. And so in order to find the total surface area, we have to add up all these portions. So it's actually equal to, so 294 is derived from adding 20 plus 18 plus 72 plus 84. And that's how we get 294. So I'm just writing it out. So if someone was to look back at this, they'll remember why. And you can write this down on your papers. Remember, you can always pause the video and go through it again. So volume is very different because, again, the surface area will be the material that will be required to, say, wrap something, or for like, you know, say, for example, you have cheese and you want to wrap it in grease paper. So then you would need to cut out the paper to the exact shape, and that's why the surface area is necessary. And for those who are building items as well, objects, they would need to know surface areas. For volume will be the content within the surface area. So that first we identify one side, which is the area of the triangle, which is the side. And so half the base times the height. So again, we'll use the same information for the area of the triangle, and then we're going to use the height. So we're going to use the height here, and then we're going to use the height, which is the length. So the length is considered the height. So in this case, we're going to do the surface, which is the triangular portion, and then the longest length, and that will cover the volume. So that's why we have area of triangle, which is denoted by AT. So that's why I have that here. That's area of triangle times height, which is the longest length, which is actually joining the two triangles together. That would be your height, which is 20. So remember, the two triangles are the front and back triangles, which is F and B. So those two triangles will be considered the base, the two sections that the object will be sitting on if you turn it upside down. And then you just multiply after you collect your numbers. That's represented by the B and the H in this case, and then height, which is the longest length that connects the two triangles. You multiply everything together. So that's why you have half times 6 times 3 times 20, which is equal to 180. And that's the area and the volume. So now we're going to look at the surface area and volume for pyramids. So in terms of the rectangular pyramid, we have to first calculate the surface area of all the triangles. So this rectangular pyramid has, the base has 4 equal sides. So we don't need to worry about the length times the width. The length and the width are going to be the same. So with that said, we have to determine what the triangles are. And because it's a perfect square at the base, then all the triangles will be the same because they're meeting each other at the vertex at the top in the center of the perfect square. So now, with that said, we know that we are going to multiply the sides because we have 4 sides. We're going to multiply the formula by 4, which is the regular formula for half the base times the height. Now we do have the height, which is a side. So if you were to take one side of the triangle off of the pyramid, remember this is like material being built to determine the sides. And because we have 4 sides. So you can see a 9 on the left here. And this 9 represents the height, which is from the vertex to the base, which is the side on the base. So any of the sides would have the height of 9. And this would be the sides of the pyramid, which is a triangular side. And so the triangles would be half the base times the height, and the height is 9. So we only need the 9 for this case. And then we're gonna do the bed mass again. It comes up again, the bed mass approach. We have to do our brackets first, and also we have to do our multiplication before we do our additions. So with that said, let's look at what's in the bracket. So half of 6 times 9. So 3 times 9 is 27. And then 4 times 27 is equal to 108. So we keep that on the side. Now we have multiplication here. 6 times 6 is 36. So we're not gonna add the 6 before we multiply it. We always have to do our multiplication first because multiplication comes before adding and subtracting in our BEDMAS approach. And so we have to add after we have done both sides. 108 plus 36 is equal to 144 centimeters square. And again, because it's a surface area, so we're going to have square in this case. Now, to find the volume, we have to determine the entire area on the inside, which means we're going to need a different height. We can't use that 9 that's over here. We can't use that. So we have to find what the height is on the inside, and this height is 8.5. So that's the height on the inside, which is from the center of the shape all the way up to the vertex, the top, the highest point. So that would be the height of the shape. And so we simply have to find the area, which is 1/3 of the area times the height. And we know the base is 6 times 6, which is really A. So A is the area of the base. So we'll call that AB, which is denoted by A, and that's equal to 6 times 6. So that's where we got the 36 from. Okay. And so that's why we have 36 here. And then we're going to multiply it by the height, which is the 8.5. And so 1/3 of 36 is equal to 12. Therefore, 12 times 8.5 is equal to 102 centimeters cube. And it's because we have a volume, that's why we have a cube. And that's how we do any surface area that has a base of a pyramid. And now, if it was a triangular pyramid, the only thing we need to do differently is just to do half the base times the height, which would be the triangle formula for the base. So that's the only thing you would change if you were going to do a triangular pyramid. You would find half the base of times the height on the base, and then because you will only have 3 triangles in that case, then you would have to use the formula half the base times the height for the only 3 triangles, and that will be your surface area. And again, your volume would have been 1/3 of the area, which would have been half the base times the height if it was a triangular prism, or a triangular pyramid. Then you would get the area of the base first, and then you would say 1/3 of the area because it's a volume. So that's why the formula must be 1/3 of the area, which is the base times the height, and then that would be different. So that's the only difference between the rectangular prism or the pyramid, sorry about that, the rectangular pyramid and the triangular pyramid. Okay, I hope that's clear. So let's look at the surface area and volume for cylinder. So here we have the figure here, which is the height of 12 and the radius is 10. So we notice that we have 2 bases here, and then we have this side that's called the lateral surface. And it's denoted by lateral, and I just put S there. So that's the surface around on the sides, and then it's joining the 2 bases, which is the top and bottom. And so we can see here, the formula is 2 pi r squared plus 2 pi r times h. So, and the reason for that is because 2 pi r squared is the circumference area of the circle. And we have pi, which is 3.14. So 2 times 3.14 times 10 squared. And again, we have to use our BEDMAS. So if we were to just say 10 squared is 100, and times 2 times 3.14, we're going to get 628.32. And we don't want to add anything until we have done what's in the bracket. I purposely put it in a bracket, even though in the formula it doesn't show that, but just to not confuse ourselves with adding too early. So we're going to add once we get everything on both sides. So we have 2 times 3.14 times 10 times 12. In this case, you notice there's no square because it's just the pi times 2 times radius times height, and in this case 10 and 12. So we're gonna end up with the total of 753.98. When we add these together, we're gonna have a total of 1,382.30. And again, centimeter square, because it's a surface area. So whenever you see area, always think square. Volume, however, we're gonna end up with a cube, just to be aware of that. And in this case, because we have 3.14 as our pi, 10 square, which is the r, and then we gonna multiply that by the height. And again, remember, the volume is whatever goes on the inside. The surface area is a material that is covering the area. So the answer is 3,769.91 centimeters, and again, cube, because it's volume. So let's look at the surface area and volume of a cone. So as we can see on the left side, the height of the cone is 28.3, the radius is 10, and the side height from the circumference at the base to the vertex at the top is 30. So we don't want to confuse that. So here to here. So the side, okay, that's 30. And then the height inside from the vertex to the center of the circle is 28.3. Just to make it clear, 28.3. So the surface area is calculated by multiplying pi r times s plus pi r squared. So for the purpose of this question, we will try to use 3.14 times 10 times 30. If you use a calculator, the 3.14 might be elongated, and if you notice, some of the answers will not necessarily be exactly what I have here, but we know that 3.14 is 2 decimal place of the pi, what's considered pi, and you can have 4 decimal places. It depends on what the question asks. And so we multiply those 3 and we're going to get 942.47. Now, if we do 3.14 times 10 squared, which is 100, we're going to get 314. And remember, in previous lessons, you would know that when you just need to move the 0 twice and you'll get 314. That's a short way of multiplying by numbers that end with 0. And so the answer is 1,256.47 centimeters squared, because it's area. Again, the volume of a cone, the formula is 1/3 of pi r squared times height. And we already know the height is 28.3, so we're not going to use S in this case. We know that the radius is 10, and we know that pi is 3.14, and we know that we're going to be multiplying it by 1/3. So when we multiply all of these 4 items, we know that the answer will be 2,963.6 centimeter cube, because it's volume. So I hope this is very clear. So for surface area and volume of spheres, we have to use this formula, which is 4 pi r squared. And the answer that we get for this formula, it's approximated. So it's not entirely accurate, but this is an approximation of what we have to use to find the surface area. And because there's no vertex on a surface area, so we have to approximate it. And we also have to determine the length, which is the radius from the center to the circumference. So when we do this calculation, and again, 3.14 is just an 2-place decimal value of pi. So we're going to end up with 12, which is 1,256.64 centimeters square. Again, it's approximated, and square because it's a surface area. Volume, however, is 4/3 pi r cube, or 1 1/3 pi r cube. And just to remind ourselves that r, which is the radius, if we are given the diameter, we can find the radius by dividing by 2. So here we have 4/3 times 3.14 average, or estimated for 2 decimal places, times 10 to the power of 3, which will be 1,000 time, and that total will be equal to 4,188.79 centimeter cube. And that will be the answer. And that ends all our surface areas and volumes for all the different objects in this chapter.
All right, let's recap. Perimeter and area for triangles, rectangles, circles, and parallelograms. These are the basics you need to master. Surface area and volume for prisms, pyramids, cylinders, cones, and spheres. Remember, practice makes perfect. The more you practice, the more confident you'll become. So grab a pen, do some practice problems, and you'll be ready to ace that exam. Thanks for watching. Keep practicing, and you'll see improvement. If you found this helpful, give it a thumbs up and subscribe for more math tips. See you next time. Keep learning and stay curious.